This is lesson 2 in unit 1 of your workbook. It's on page 14. So this is where we're starting today. We have a figure and 2 copies, each with some points labeled. So when you look at those figures, you may start to notice some things about them. So let's first just complete the table. We're going to show corresponding parts in the 3 figures. Corresponding means which part is in the same place. So when I look at this and I see point P in the original is right here. So which one is in the same place as that would be point F in copy 1. And then look for the point that's in the same place on copy 2, which would be point Z. Fill in your workbook as I'm filling in mine, because you're going to want this. You can stop the video at any time and give yourself more time to write and then come back to it. Okay, segment LM is right here. So I'm going to want to come over here and look for the one in the same place, and it would be BC. Segment BC. And if I come over here, it would be segment VW. They all sit in the same place. Okay, segment EF in copy 1, because remember this is copy 1, so I come here. What would be in the same place in the original? Well, OP, segment OP. Now, does it matter if you call it OP or PO? No, it doesn't. You can do either way. And then in the last one, I was looking for the same as EF, so that would be YZ. We're just matching things that are the same right now. So now I look at point W on copy 2. Which one would be the same? Point C on copy 1. And on the original, WCM, point M. Okay, angle KLM. When we say an angle, the middle letter is always the vertex. So KLM is talking about this angle right here, KLM. So what would be the same? Looks like ABC. Could I call it angle CBA? Yes, the B has to be in the middle. That's the only stipulation on that. So then I go to the next one, and it would be angle UVW. And on the last one, it says angle XYZ, so it'd be angle DEF. And angle NOP. Okay, do you think either copy was a scaled copy of the original figure? So I'm going to stop here. You're going to have a question, answer it, and then come back, see what the answer was. Is either copy a scaled copy of the original figure? I think maybe copy 1 might be. Copy 1 looks similar, just smaller. What do you think about copy 2? I don't think so. Copy 2 looks flattened. So it may not be a scaled copy. It looks flattened, but I don't have measurements to be able to tell if the segments are the same. So what should I do? Well, it says use tracing paper to compare the angle. Can we compare angle KLM with its corresponding angles in copy 1 and copy 2? So let's just take a piece of tracing paper here. I have a overlay, and I'm going to put it on top of the original, and I'm going to sketch KLM. I don't know why that isn't working. Let's try it here. KLM. I'm going to have to get a different one, I think. Let me just be right back. Okay, we're going to try this one. We've got KLM. Now I'm going to move it over and see if it looks the same as ABC. It does. It kind of matches up on those lines. If I put it over here, is it the same? No, it's not. Okay, so that leads me to believe that maybe copy 1 is a scaled copy because its angles are the same. So what did you notice? You need to write what we saw. Copy 1 has the same angle measure. Okay, and then it says use tracing paper to compare NOP. So I'm just going to take another piece of this. You can watch in the video. I've got NOP. When I move it over, is it the same as DEF? Yeah, it does look the same, doesn't it? But if I move it over here, does it look the same as XYZ? No, it looks smaller now. So copy 1 again seems to have the same measure. So this would lead me to believe that copy 1 is a scaled copy. It has the same angle measures. Copy 2 is not. So let's make a note here. Same angle measures. All right, let's go on to the next activity. On 2-3, what we have is a lot of different triangles. And what we're going to do is see which ones of these triangles might be scaled copies. And the way we're going to do this is we're going to compare with a ratio. So you're going to get your calculator out. You're going to be using it. And let's take each one of these sides and divide them by the similar side. Well, if I look at A, I don't even need to do that. Because look, this one has a right angle. Do you see a right angle in A? Here's your right angle, a 90 degree. Is there one in figure A? No. So this is not a scaled copy. We might write no right angle. That's how we knew. Does B have a right angle? Yeah, and it seems to be in the same place. In fact, all the sides are the same. 3, 4, and 5. So I know that B is a scaled copy. You can put it down here in your chart. B is a scaled copy, and its sides were exactly the same. 3, 4, and 5. Okay, some people like to forget that a scaled copy can be the exact copy of something, but it can. It doesn't have to be bigger or smaller. It could be the same. So let's look at C. We have the right angle, but we need to check because I'm not sure about some of these measurements. So let's take 2 and divide it by 3. That's making a ratio, comparing the two same sides. And I'm going to take 5 and divide it by 4. So in my calculator, 5 divided by 4 is 1.25. 2 divided by 3 is 0.67. So these do not match. They all have to be the same ratio for it to be a scaled copy. We learned that last week, so that would be a no. Let's look at D. I can take 2 and divide it by 4. Oh, I know what that is. That's a half. What if I take 5 halves and divide by 5? 5 halves divided by 5 is 1/2. We better check this one. 3 halves divided by 3. 3 halves divided by 3 gives me 1/2 too. These are all the same, so yes, D is a scaled copy. So we're going to put it down at the bottom, D, and then we got to match the sides. The same side that's the side of 4 was a 2. 5 halves where the 5 was, and 3 halves where the 3 was. So again, you can compare yours up here. That's what we have. So now let's go to E. We have the right angle, 4, and then we have 8. Well, what's 8 divided by 4? Well, that's 2. What's 10 divided by 5? 2. 6 divided by 3? 2. So again, we have another scaled copy. And we're going to put it in our chart. E was a scaled copy. And the side that was 3 was 6. Side was 4 was 8. And 5 was 10. Let's look at F. Oh, look, no right angle. So we know this is a no. No. No right angle. Let's look at G. 10/3 divided by 5. Gives me 2/3. 2 divided by 3 is 2/3. And 8/3 divided by 4 is 2/3. So again, I'm taking each side and just dividing it by the size of that original. And these were all the same, so yes, G is a scaled copy. I'm going to come down here and fill in what was the same. The side of 3 was a 2. The side of 4 was 8/3. And 10/3 was the side of 5. Okay, so we have now made a table, and we want to start to be able to compare which things, how did they change? How did we go from the original to B? Well, it stayed the same, really. So you were multiplying by what? 3 times what gives you 3? Well, 1. So to go from this row to this row, we multiplied by 1. And then we went from 5 to 5 halves, from 4 to 2. What are you multiplying by now? 3 to 3 halves. You're multiplying by 1/2. And then we went from 5 to 10. Now what did we multiply by? Oh, well, that was a multiplication of 2. We multiplied by 2. And then I go to the last one. What did I multiply by to get from 3 to 2? From 4 to 8/3. It's a little harder to figure out, but you're multiplying by 2/3. It's 2/3 times bigger. So what do we call this number? This is our scale factor. Scale factor. It's how many times bigger the second object is. Okay. Now, in summary of today's lesson, I'm going to have you stop filling out there and go to your notes, which will be right here. We've learned 2 different things today. We learned about corresponding parts, and we learned about scale factors. So let's draw a triangle. A rectangle. And we're going to say that this side is 3 and this